All right, fine. Let's have a look at this one then. So we have lines L1 and L2 have vector equations given as this. Okay, so I'll actually just write those down. So we have L1 given as, okay, now just remind me, when I write this down, so r equals 4 to negative 6 plus, what was it, lambda, no, mu, lots of negative 8, 1 and negative 2. Now let's just pause for a second before I jump in with the second equation. Just remind me, what's going on here? What does this mean?
It's a line equation.
Good. So we've got a straight line. How many dimensions are we working with?
3.
3 dimensions, okay, so we've got left and right, forwards and backwards, and up and down, or no, left and right, up and down, forwards and backwards, that way around, okay. Okay, what does this part tell us?
First part?
Yeah, the 4 to negative 6.
It's the intersect point.
Kind of, yeah, exactly, it's a position. Yeah, no, absolutely right. So we'll call this part a position vector, right? So I'll just write pos for short. It's a vector which actually gets us onto the line. And you're right, if you're thinking about the general equation of a straight line like y equals mx plus c, then that is kind of like your y-intercept. It's telling you how high or low that line is. Perfect. What's this vector telling us? The negative 8, 1, negative 2?
Slope.
Good, exactly. It's the slope or the gradient. In this case, I'm going to call it the direction vector. Okay, so direction, or DRL for short. It's kind of telling me which direction my line is facing in. So in other words, if I go along the vector negative 8, 1, negative 2, it's going to be a vector which is in the same direction which this line is facing in. Yeah? So I've got onto the line with the position vector, I'm going along that line with the direction vector. So what's the mu got to do with anything?
What's this? Trace the scalar. So kind of.
Good, absolutely. It's a scalar multiple. Yeah, good. So yeah, it's a scalar multiple. What this literally will tell us, so this is our scalar, is look, think about my direction vector. My direction vector negative 8, 1, negative 2. In fact, let me just quickly draw a quick sketch. And I'm going to draw it in 2 dimensions just to illustrate what is actually going on here. But of course, we're working in 3 dimensions here. So here's my line. Okay, so I'm just going to say this is my line. So the idea is that I have a position vector. In other words, I have a vector that starts from the origin and goes to some point that I know definitely lies on that line. That's my position vector part, okay? So actually, let me just draw it as a vector with a line. Okay, so that's my position vector, right? I also have a direction vector. Now this direction vector I know travels in exactly the same direction as this line. Okay, so that's my direction vector. Now the reason why I have a scalar in there, the reason why I have a scalar multiple, okay, is because this r is just some general point that lies on the line. In fact, it's a position vector which gets me to some general point on the line, okay? Okay, so this is some general point, but obviously it's the position vector which moves me from the origin to some general point. So let's suppose, for example, my general point is out here, okay? So this is my point R. Okay, so I'm thinking about the position vector which moves me from the origin to the point R. Well, clearly, if I'm doing it in terms of my position and direction vector, my position vector gets me onto the line. Then when I'm here, I have my direction vector which moves me in the same direction as the line. But if I want to actually physically get to R, I might have to move, say, twice my direction vector, or 3 times my direction vector, or negative a half times my direction vector. Just some scalar multiple of my direction vector ensures me that I can get to any point which is on this line.
Yeah.
That makes sense?
Yeah.
Yeah? Okay, so that's the reason why I've got that scalar in there, basically. Okay.
We have direction vector.
Yes?
Why do we need a scalar multiple?
Okay, so exactly that reason, right? I want to get to some general point in the line, right? At the moment, let's say my direction vector is too short.
This direction vector.
Exactly.
Okay.
Yeah, so at the moment I might be saying, well, my direction vector is too short, right? So I need to make it longer. That's what my scalar is doing. It's making it longer or shorter, right? Or it could be the same length if it's just one, right? So this is really all that's going on here. I move along my position vector to get on the line, then just moving some length of my direction vector will move me to my general point R, right? So that's kind of, what I want you to see here is I want you to understand each of the different components, because it's actually a very simple idea. All right, so just for the sake of this question, I'm actually going to get rid of these annotations in blue and red underneath, because I'm going to actually just write down the second line, which is, so still some general point R, it could be the same point, it could be a different point, is equal to a different vector this time, so -2, A and -2, plus, I'm just going to use a different scalar, but it's the same idea, lots of a different direction vector, which is -9, 2, and -5. Okay, so hopefully you can see this is just a different line, right? I should also mention as well the reason why we use a vector equation as opposed to our old friend y equals mx plus c or y equals mx plus b, whatever you are used to using, is because y equals mx plus c is great if you're working in 2 dimensions. As soon as you start working in 3 dimensions, Cartesian equation becomes a little bit more awkward, right? It's not actually that bad, but it's still a little bit more awkward. So it's just easier to think in terms of vectors because it still translates quite nicely. Okay, so the questioner says, given that these 2 points or these 2 lines intersect, okay, they cross each other, can you find the intersection point, or can you find the value of A and the point of intersection, right? So in other words, I'm telling you that these 2 lines intersect at some point. I'm going to call that point P. Clearly, I've got some unknown in that second vector equation of my line, right? So first of all, I need to find out what that value of A is. Second of all, once I've got that, I should be able to find that point of intersection. So any ideas for how we could go about doing this one?
Remember, we could look at the multiple of the gradient, but this thing
First set L1 equal to L2.
Good. So we're going to set L1 equal to L2. Why are we going to do that?
They're not parallel.
Okay, so they're not parallel. How do you know they're not parallel, actually, interestingly? So they're not, but how do you know they're not parallel?
With looking direction vectors,
Uh-huh.
they are not, how can we say?
So looking at the -8,
And -9,
1, -2. Yeah, go on.
also 1 and 2, they are not parallel.
Okay, so how do you know that? So these are my 2 direction vectors, that one and that one. How do you know they're not parallel?
One of them is not the others any 2 times, 3 times, or
Good, exactly. So you've got the same idea, right? Perfect. So in other words, if they were parallel, there would be some scalar multiple, let's call it k, which exists such that these 2 things are the same. Because clearly, if they're the same vector, right, they would have just some scalar multiple off of each other. They'd still be traveling roughly the same direction, effectively the same vector. So in this case, if I actually solved for k, I just get k is equal to all sorts of different things. So in the first case, for the I direction, I get k would be equal to 9 over 8.
8.
Yeah?
Yeah.
And for the j direction, what would I get k? Yeah. And for the k direction?
5 divided by 2.
Yeah, 5 divided by 2, perfect. Now, obviously, I probably shouldn't have used k, given that we've already got direction for k, but you get the idea, right? Because these things are not scalar multiple. So actually, when we're going through this, I will talk you through a different type of question in a second, or at least allude to a different type of question that I could ask in a second, but just keep this in the back of your mind. So maybe just park this over on the right-hand side. So it's really good that you're thinking about that already, okay?